Hello, Matthews Gatos here. In this video, we're going to look at volume and surface area of a sphere. So what exactly is a sphere? I kind of think of them as a three-dimensional circle. So like basketball or a globe or an Easter egg. Those are all spheres. The math definition is a three-dimensional shape in which all points are an equal distance from a fixed point called the center. So if I connect the center of the sphere to any point on the circumference, those would be a radii. If I were to go through the center connecting 2 points on the circumference all the way across, that would be a diameter. So the relationship between radius and diameter is that 2 radii equal 1 diameter. Or you can say the diameter divided by 2 is equal to a radius. So let's come up with the surface area formula. Now, surface area of a cylinder and surface area of a sphere are very closely linked together. So imagine you have a sphere that has the same radius as the cylinder. You can see I can put it in there into the sphere, but I have a little bit of extra, and I have a little bit of extra on the top and on the bottom, but we can just see the top. So imagine this extra strip right here. If I were to use scissors and I were to cut, let's say this was paper, and I was to cut all the way around, and I can't show you on the inside, but cut all the way here, and I were to fold all of those pieces in, it would cover the entire top of the sphere, and I can do the same thing on the bottom. So what that tells me is that the lateral area of the cylinder is the same as the surface area of the sphere. So let's talk about this sphere here. So here is where it lines up, and I can see they have the same radius, but let's talk about the height. If I go from the center of a sphere here, that's a radius, the center of the sphere here, also a radius. So altogether, what we call the height of a cylinder in terms of a sphere would be radius plus radius, or 2 radii. So let's use that to come up with the surface area. So as we saw, the lateral area of the cylinder was equal to the surface area of a sphere. So there's the lateral area of a cylinder, and that's the same as a sphere. Except a sphere doesn't have height h. We see a sphere has a height of 2 radii. So to simplify this, I'm just going to multiply my 2's together and my r's together to get that the surface area is 4 pi r squared. Okay, let's use that in a question. So here we have a baseball, and it has a diameter of 3 inches. Right away, I'm just going to do diameter divided by 2 to get the radius. So 3 divided by 2 is the radius, so the radius is 1.5. Now we want to determine the surface area, so the amount of leather it would take to make that Major League Baseball. So I'll start with my formula, 4 pi r squared, and then I will make substitutions using brackets. So I'm going to have 4 pi times 1.5 squared. So let's talk about how we can enter that into our calculator. So I'm going to do 4 pi and then bracket 1.5 squared. So variable key over to the left here. And then press enter, and that would be my surface area. So let's go back and round it correctly. So we want to round this to the nearest square inch. So that means whole number. So I'm going to take my answer I got on the calculator. I'm going to look at my ones digit, look to the right, and that tells me to leave my ones digit alone. So the surface area is going to be 28 square inches. Okay, let's talk volume now. So back to the cylinder again. Now, cylinder and sphere, let's say they have the same radius, and we already established that the sphere has a height of 2r. Let's compare their volumes. If I were to fill up a sphere entirely, it would not entirely fill up a cylinder. It would actually fill up 2/3 of a cylinder. So one sphere fills up 2/3 of a cylinder with the same radius. But we can use this to calculate the formula of volume of a sphere. So volume of a sphere is 2/3 the volume of a cylinder. Well, we know volume of a cylinder is pi r squared h. So the sphere will just be 2/3 that. Now with the sphere, we don't use h for height. Remember, we measured the height to be 2 radii. So now all I have to do is tidy this up. So I'm going to multiply the 2's together and the r's together. So I'm going to get 2 times 2, 4. R squared times r is r cubed. 4/3 pi r cubed. Or as I like to write it, 4 pi r cubed divided by 3. So now that we know the formula, let's use it back on that baseball to find the volume. So again, we know that the radius is 1.5 inches from the last time. So volume 4 pi r cubed divided by 3. So I always want to start with my formula first, and then in the next step use brackets to make my substitution. Okay, so let's again go to our graphing calculator to figure this out. So I'm going to show you how the 83's would do it. So 83's, we're going to use brackets for our numerator. So 4, pi is above the exponent key, so second exponent key. Bracket 1.5. Now we're cubing it. We have a square button here, but we don't have a cube button. So I need to use my exponent key and then enter in a 3. Toggle over, and there's brackets for my entire numerator, and that's divided by 3. So that's how I would do it on the 83. On the 84 or the 84 plus, I have a fraction template I like to use. So to get that, I do alpha y equals, press enter, and then we have this fill in the blank fraction. So I'm going to go 4 pi, and then bracket. So I'm doing it essentially how I just wrote it out on our notes. And then exponent key 3. Press the down arrow to get to the denominator, and I get 3. And you can see I get the same answer. So back over here, to round it to the nearest cubic inch, that means whole number. I look to my ones number, I look to the right, which is a 1, which tells me to leave the 4 alone. So my volume is going to be 14 cubic inches. Last thing I want to talk to you guys about is hemispheres. So if a sphere is like a globe, the hemisphere would be half of it. So that's why when we talk about the globe, we talk about the northern hemisphere and the southern hemisphere. It's like the Earth split into 2 equal pieces. So a volume of a hemisphere is half the volume of a sphere. Well, we just figured out the volume of a sphere. It was 4 pi r cubed divided by 3. So if we take half of that, let's use what we know about fractions, multiply the numerators, multiply the denominators, and we get 4 pi r cubed divided by 6. All I have to do then is reduce my fraction 4 over 6, common factor of 2, and I get 2 pi r cubed divided by 3. Now, this is not on our formula sheet, so it is definitely worth memorizing. I want you to memorize that formula. So volume of a hemisphere, 2 pi r cubed divided by 3. Let's talk surface area. Now, the surface area of a hemisphere depends on if we have a hollow or if we have a solid. It didn't matter for volume because this would be like a bowl or a bowl with a lid. Well, both of those have the same volume. However, they don't have the same surface area. So imagine we have a hollow hemisphere. So there is nothing on the top. It's like a bowl with no lid, okay? If we took half of the surface area of a sphere, we would just get the bottom bowl part, okay? So we would take the surface area of a sphere, which we know is 4 pi r squared, take half of that, well, half of 4 is 2, and I would get the surface area of a hollow hemisphere, 2 pi r squared. Again, you need to memorize this. It's not so bad, though. Now, imagine that I had a solid hemisphere. So this could be a bowl with a lid, or maybe a watermelon that's solid. If I take half the surface area, again, I just get this bowl part here. But I have to remember that the top part is solid, and that's also a circle. So I take half of the surface area of a sphere plus this extra area of a circle on top. So in terms of the formula, I take half of the sphere plus the area of the circle on top. So we already know half of 4 pi r squared is 2 pi r squared, but we have that area of that extra circle on top, which means that the surface area of a hemisphere that is solid is 3 pi r squared. Again, I want you to memorize this formula. So let's try an example. So I want to do the hemisphere that has a diameter of 14 inches. So right away, I do diameter divided by 2 is the radius. So I know the radius is 7 inches. I want to calculate the surface area and volume to the nearest tenth. Now, a little tip for you in the corner there. A hemisphere is solid unless otherwise stated. So I'm going to use my solid formulas. So the volume is 2 pi r cubed divided by 3. So I always start with my formula, and then in the next step, I just use brackets to make my substitution. So there I would have 2 pi 7 cubed divided by 3. So I would enter it into the calculator using my fraction template that I just showed you. And I want to round this to the nearest tenth. So here's my 10th position, the 3. I look to the right and it's a 7, which tells me to round it up. So my volume will be 718.4. And I believe my units were inches, yes. And this is volume, so they are cubic inches. So really pay attention to the rules of rounding. Now, surface area, it is a solid hemisphere. So you have the bottom half, 2 pi r squared, plus the circle on top. So again, start with your formula. Surface area is 3 pi r squared. So that's going to be 3 pi times the radius squared. So I would put it into my calculator exactly as I've typed it there. And again, I'm rounding it to the nearest tenth. So I look at my digit 8, I look to the right, which is a 1, and that tells me to leave it alone. So it would be 461.8, and surface area is square inches. So now you've seen volume and surface area of a sphere and a hemisphere. So I just want to end with a question for you. Who do you think would win in a boxing match, a sphere or a cube? Well, in my opinion, I think it is going to be the cube. Now, why is it going to be the cube? Well, simply put, I think it has an edge. So I hope this video helped, and I look forward to seeing you guys for the next.